Cheers. So I would assume that at least a few of you guys have experience with Ruby on Rails and Monolith or something similar. Okay, raise your hands. Oh yeah. Okay. So you probably all faced the moment where you couldn't scale anymore in terms of, not in terms of power, but in terms of features and complexity of your code. So when we joined MyMeds&Me, there was a Ruby on Rails app, and it was kind of working prototype, which was sold to the first customers later on after some improvements. But it was pretty clear from the beginning we need to improve the system in order to scale the business. And I want to take you there to this journey, which is much more, I'm afraid, an architectural and design talk, less a coding talk. But at least I want to explain in the end, so why did we choose Elixir and why Elm? And how does it fit together with microservice and a bit of infrastructure automation? So MyMeds&Me provides a software as a service, which is called Recursion, and it's tracking adverse events. So if you have a headache and you take aspirin and you get really bad stomach, then you can report this adverse event in an online questionnaire. So this is probably one of the first times that adverse events can be reported in a systematical way. We're a small startup in Soho, not anymore Soho, actually Holborn, London, and we have about 28 staff members, like 7 developers. We started with 2 customers, Pfizer and Allergan, and it worked quite well. We could provide all the features they wanted, we customized it, but at a certain point we were running into troubles. So this is the stack we're running on, nothing really awkward. The limiting factor, or the restriction we have to provide GxP compliance, because when you work with pharmaceutical, you always need to host your environment in controlled environments and have kind of documentation of the changes you did. So the mission we were starting almost a year ago was scale the business without scaling linear the team. And that's kind of problem for us because, like I said, the application works well, but we have some fundamental challenges with business and functional requirements that makes it hard for us to scale in terms of number of clients, number of features, number of products, but we get there. So what's actually wrong with a monolith? We all started perhaps with a monolith, and actually it works quite well, right? It's easy to install, you can host it somewhere, you understand the whole process flow and communication flow, and you can debug it easily. Well, at a certain point, if you add more and more functionality, that leads to entropy of the system. And, well, in terms of climate change, you may understand this better. At a certain level of new quantity, we getting into a new level of quality. So if, like for example, the average temperature just rises by 1%, we might not have any poles. 1% doesn't or 1 degree doesn't sound that much, but it's just the tipping point. And at that stage, it becomes critical, mission critical, at least for human mankind. So, and we have the same kind of in software, because entropy leads to complexity in the code. And then it becomes harder to maintain the functionality and extend it with new functionality. So the case with MyMeds&Me is we have a growing platform. So we have ahead of us a couple of new clients and new products coming up, and they're all kind of diverging. So they won't have the same functionality. They are highly customized, and they have probably different versions they run on. So, I didn't mention that although we have a software as a service, the problem is it's hosted per client. So that means that we have for each client all the environments up and running, and they probably run all in different versions. With 2 customers, 2 versions, no problem. If we get to a bigger number, it will get harder and harder. So in our case, the new quantity means instead of 1 product and 2 customers, 2 versions, we might end up by 2020. This is a bit a hope we have, up to 4 products, 20 customers, and maybe 20 versions, maybe only 10. But I'm trying to exaggerate the example a bit here, just to make the point clear. So if you have up to 4 different products multiplied with 20 customers, you end up probably up to 80 different versions. Then, given that we have like at least 4 environments per client, that runs a number on a host, which is hardly to take just in first step, because 320, we're doing hard managing like, I don't know, 20 environments. So that's a different scale. That's a definitely different quality. The result of this is the platform complexity grows exponential, kind of per product, version, and customer. And that means in the end we have decreasing productivity, extendability, and maintainability of the platform. And the outcome is an imploding kind of time to market and stability, and exploding costs. So how should we deal with this? Well, there are in general maybe 2 quite extreme options. One is the turtle tactic. Did you know actually that turtles lay their eggs like, I don't know, 30 meters away from the sea? And they do it every time. So it's kind of genetic thing. If there's flood, whatever, they still do it. They can't change their tactic. They just use the behavior they got inherited with their genes. There's a second option. I call it raven tactic. They're actually quite clever. So they find always kind of tools to get around with the situation and find a solution for it. Well, I would say let's do the second one. And if we do so if we want to be smart about how we deal with this new quantity and quality, we actually have to find some solutions for some of the business problems, some of the problems which are generated by the business. One is, so like I've said, we have tailorized products per customer. So for 1 and 2, again, that's fine. But then we have to think about all these questionnaires we have. They have to map a data structure. If they diverge, and we have like 20 of them, that's going to be a problem. At the moment, it's really pity to say, but the consultants who set up the platform in the first place, they use, I don't know if you guys know Cell. It's kind of a gem in Ruby on Rails for component usage. It's getting really out of control if you leave your logic inside these little components. So we have now reusable UI components which are spread all over the questionnaire, and actually we have like 80 of them, and the logic, how the whole questionnaires are set up, are distributed in these UI components. So that doesn't scale very well. We thought about we can come up with a different solution and put all this complexity into a graph database so that we can fully generate the UI and test it automatically, and have some validation checks as well. The next problem we have, is sparse data, because every user fills out the form quite differently, and depending on what he has answered in one question, he might get different triggers for follow-up questions. So the data model is really not really stable and robust. And at the moment, it looks like this. It's a JSON blob in Postgres database, and this is really hard to deal with. So we thought, given that we use OrientDB, which has not only the option to structure graph data, but also document data, we can actually store the data in a way that's connected. In this case, we just have a central report with different report sections. They're all linked together, and because these kind of joins are very cheap and fast in OrientDB, we can query them in nanoseconds. So that provides us also the possibility to run analytics on them, real-time analytics. At the moment, try to query JSON blobs over different database entries. That's quite hard. So another problem we had is, since all the logic is kind of, or a good part of the logic is inside the UI components, exchanging the UI by a different UI, or providing a kind of API for a mobile is really hard for us at the moment. And this is also a problem that the backend and frontend are tightly coupled. So you can't exchange one of them without breaking things and parts on the other side. The idea we had was to say, okay, we can use WebSockets, decouple entirely front-end and back-end, and then we can say, you define a kind of API and they can talk to each other just using this API. And then it doesn't matter if it's a mobile device or a browser, we can render, or we can generate different UIs just with the data we get from the backend. So the products we have, they're quite similar, but then they vary in certain bits. Like, we have a general adverse events kind of product, but then one which is specific for clinical trials, and they have very advanced kind of requirements. So the data model can change within one study, for example. So we don't actually want to link them together. But if we set up a new product, We can't just say we want to use authorization, the questionnaire part, and reuse it in the new product. This is something we wanted to provide in the new platform. And the tight coupling between the modules make it also hard to refactor bits and pieces. So if we change, for example, just the data model a bit, that will cause us a lot of problems. The alternative we just found, and this comes with a kind of drawback, but is a microservice, because it leads to a very self-contained service approach, where you can say each service has its own, database model, its own database schema. If you need to scale, you can provide a separate database server as well, and you can deploy them individually. Of course, there are dependencies between the servers, but in the end, if you don't have breaking changes, you can deploy your update in your service without touching the rest of the code. And that's actually a big deal for us, because we have not only user acceptance tests from our clients before we release something, it needs to be tested and documented internally as well. So we have formal testing and manual testing, and that has to provide all these documents which kind of use cases we tested. And that becomes really unwieldy if you have to do the full regression test with every single change. Another one is regarding this. At the moment, we have a strict separation between ops and devs. But if you want to bring in more customers and set up more new components, that gets harder as well. Because we use an approach which is infrastructure as code. You always deploy updates on a server and change just the configuration on top of it. Sometimes you don't really know what is the latest change on one instance. So dealing with a lot of customers in different versions becomes kind of a risk. Since we use or want to use microservice, the container approach provides an alternative where we can have more infrastructure as state, and can say we have an image and we created a container and that runs on integration, and we know it will work on staging as well, and we can deploy it without risk. So if you imagine we had all these different customers and all these different versions and products, even for deployment and handling the infrastructure, that becomes a difficult job. And I think something like automation and also a very strict process can help to provide a better throughput. At the moment, we do a lot of stuff like on demand, and we have to trigger some jobs and provide that one demo server is running right in time for our sales guys. What we want to do is a kind of orchestration of all the containers, so you don't have to worry manually in which kind of configuration setup this certain environment runs. We can just promote the changes we did on integration, because we tested them as developers, to staging, and then our BIs and also our testers can check the latest changes. And the good part about this, so each little boxes like back-end, front-end, and these can be deployed individually, so we have less risk of change. So how does it all work together? We had some good ideas maybe, but how does it all work together? We had a vision. This vision, like, all visions are very long-term. And it's not like that we're any near there yet. But the vision can help us to, move towards this goal. So internally, technically speaking, we call it Perceptrix. And it's all about, data transformation, propagation, parallelization in real time. So we want to know if a user enters his adverse event, who has similar things reported and can maybe see if there's any sign of a pandemic in North America, for example. So Perceptrix comes from perceptron, artificial neural network, and you want to actually kind of qualify the data you get as an input and then make decisions on it after you have better qualified data, actually. And Perceptrix is like many of these perceptrons connected in the matrix. But like I said, this is just a vague idea, but it helped us to design the kind of architecture. The architecture looks like this, and it's probably not very well common for Elixir or Erlang kind of setup. So we said, don't worry, I will get into each part. We said we want to split up everything individually so that we can deploy it individually and have one central broker which takes the technical concerns of the WebSocket handling. And this looks like this. So up front we have the load balancer, but behind it we used actually Phoenix to handle all the WebSocket connections. In this case, Phoenix is quite dumb. It doesn't do anything else than forwarding the messages we get from the WebSockets. The good part is we can scale it, and it doesn't have any business logic inside it. So if it crashes one process, it doesn't matter. This is the way we try to forward the messages. So we use RabbitMQ with Phoenix to propagate the messages from the WebSockets to the backends. Why do we do this? I mean, life could be easier just using Elixir process. But once we start using Elixir process and the backend services talk directly to each other, they're not independent anymore. So we can't say the next service will be implemented in Golang or something else just because it's, for this certain case, the better tool. Also, the risk of, while you refactor your code inside the service and you break something, is bigger in terms of it's not that obvious. You don't have this API where you can see what can break and what can't break. And for data synchronization between the service, because each service has a separate database and holds only the data or writes only the data it's responsible of, like, authentication is responsible for the user data, and data capture, so the microservice who takes all the data from the online questionnaire is responsible for report. But what if I want to use user data in data capture? Well, if you use the same database like authorization, then it's not independent anymore. You can't deploy it without having dependencies on schema changes and authorization. So that's why we want to just replicate the data and take only the information we need for data capture, because we don't want to see when he was logged in last time, or we don't need single sign-on kind of permissions. Yeah, and these are the services we have at the moment. I have to say we just have provided a demo version for a sales pitch yet, so we're not into production. This is the goal for the end of the year, to provide a solution that we can host into production. But the idea is to have, per concern, and this is authorization, integration, like system integration, and data capture, separated, isolated service for backend and frontend. So, and then backend in Elixir and the frontend in Elm. So the approach, why do we actually want to use messages to communicate between these services? Well, it's all about dependencies, and so one option we would have would be using REST and using synchronous calls. But then if you see the picture on the left-hand side, you end up with various kind of dependencies between the service. And once you have more than 3 services, let's say 10, this becomes even more troublesome, because if you take down one, the other ones might not work. Especially because you have a distributed system, you have to ensure that you provide solutions for fault tolerance, not only within the service, where Elixir of course helps, but between the service. And our solution, we have chosen the event stream, provides a possibility where you have a broker in the middle. And this broker, in this case, is Phoenix. It gets every WebSocket connections and pass the messages through. So we only have to ensure that Phoenix is up and running, and we can cluster it and scale it like we need to. On the other side, it's the same with RabbitMQ. And these kind of systems are made for scaling and fault tolerance. Yeah, so I'm pretty much covered this, I think. Well, actually, why Elixir backend service? First of all, it's functional. This has some implication, especially if you have a distributed system, you need to scale it. The functional approach is much easier to handle, especially if you think about immutable state. When you have to deal with concurrency, then it also helps to, don't run into any conflicts. Pattern matching and recursion is very helpful for an approach which is mainly event-driven or message-driven, where you have to pass data and transform data, and you want to do it probably in a big scale also from, querying the database, getting the data out, providing it in a shape that it can be read from the UI. And protocols and meta programming, they help us. So first of all, protocols are always good to ensure that we have different kind of options that we can say, okay, in this case, for example, for the integer, we have a different implementation of the protocol. And this is really handy, especially if you combine it For test case, we have used metaprogramming to extend the usual test case for our scenario for integration tests. And it's so powerful, with a few lines of code, you can extend the original test case and provide the functionality you need for all your integration tests. Concurrent programming, I think, with Elixir is kind of made simple in a way that you know actually what is the state, and you can handle it with the patterns you get from OTP. I think in a non-functional language, this is much harder. And since we have a distributed system which is supposed to be event and message driven, this is actually quite helpful as well. Also, we can scale as many processes as we need for the service we run, like data capture. Well, our clients, I don't know, your clients, bet it's the same. They don't like downtime and they don't like any, failures. So in our case, it's very critical as well. And a fault-tolerant system helps really to provide a reliable service where we can say, okay, we're gonna deploy it even on Sunday because the customer can only take care of their integration system on Sunday, but we don't have to be worried about the deployment because we know, the code itself is fault tolerant. Even if one process crashed because we have a problem, the another one picks it up. And the interesting part is that actually, Kubernetes, for example, provides helpful approaches to provide the fault tolerance of service if they crash. So they can, with a health check, you just have to provide a health check API of your service and can bring up your Elixir service again. So this is actually the summary. I think in the end, what we gain, hopefully, is high productivity and low maintenance code. So whatever people implemented, I've talked to, they always said, we installed it and then we totally forgot about the service. It's just running. Another thing is, data transformation is for us one of the keys, and with a functional programming approach, that's quite easy. And the most important bit, of course, scalable and fault-tolerant applications. Well, Phoenix helps us with its kind of architecture for the WebSocket approach, because it's very performant and scalable, and we don't have to worry that if even one process crashes, the whole system will fail. So why actually Phoenix? There are several reasons. I mean, one is we can provide authentication with it. We can use pattern matching and the beauty of Elixir, but also, plug is a really cool concept. It's very easy. It just functions, and you can extend your controller and your routers in the way you need to, and it's not really hard. The thing we haven't actually considered is to use Phoenix PubSub with Redis, just because, as far as I know, at the moment there is a client for Ruby on Rails, so you could communicate via PubSub with Rails using a gem for Phoenix PubSub and using Redis, but we decided to use RabbitMQ because we just had the transactional messages for the data synchronization already in RabbitMQ. But maybe this is something which will, expand in the future, so there will be other clients as well and other use cases. In the end, we get a very high available dump and secure broker, and a central instance for cross-cutting concerns. And when I'm saying cross-cutting, then I mean more non-functional, like logging and all this stuff. And that's really helpful in a distributed application. It really helps to see just in the log file, so what kind of message got in from the browser, from the UI, and how the different microservices responded, and what was the result that got back. Yeah. So I think the nice part about this, I don't know who of you is familiar with it, but if you use more a request kind of approach with microservice, there's kind of pattern called a gateway API. So the client connects through the gateway API to the microservice. This helps to exchange services and so on. But actually, using a more message and event-driven approach, this is kind of performant because, first of all, WebSockets, they just need to get the TCP connection once, and then you have, permanent connection, very fast communication, and also because actually the sender doesn't know who's sending the message to, you can change the receiver of the message. For example, if data capture is not, feels not responsible anymore to get the data for reports, then it can be just picked up by another service. And you don't have to change any configuration or pointing in your API gateway. So I think that's for us a solution that works quite well. So RabbitMQ, I think I don't want to talk about this too much because everyone knows it, and it's really around there for a while, and it's very reliable, performant, and provides really nice solutions because you can pick up any kind of patterns, not only pub/sub, but also RCP. So we do direct RCP calls via RabbitMQ as well, and that works, yeah. And then you can use, if necessary, transactional handling, and it provides kind of persistence of the queues. This is kind of critical, especially if you want to, synchronize data between servers. And of course, it has a management interface that makes the developer happy. Yeah, it's highly available, resilient, and reliable, so we don't have to worry about it. Once it's clustered, it's fine. And we can use this for both kind of use cases. So for the inter-process communication between the microservice, but also which are, they don't really have to be, transactional. That would be a big overhead. But we can use transactional handling and persistence for the data synchronization. Right, so in the end, it helps us to keep actually the backend service with an technology agnostic approach. So if we want to provide a new backend service in a different language, it doesn't matter. It doesn't have to, use Phoenix or whatever. It just needs to have a client for RabbitMQ, and this is probably widespread over all languages. Yeah, so Elm. This is kind of interesting since they changed yesterday, or they announced to change the API. I haven't changed my slides that much for it, but well, anyway, so why did we came up with Elm actually? The last kind of JavaScript framework we tried was React.js, and it works. There were no complaints. But once you use npm for dependency management, and you have continuous integration and build with containers, that gets really tricky because sometimes just modules disappear on npm. It runs forever, and it fails quite often. So we had just the opportunity to have a look around what kind of alternatives are there. And Elm was for us kind of nice because not only it's functional, and it renders, compiles actually JavaScript, HTML, and CSS. So you get compiler checks. It's static type. Most of the time, if it compiles, it will run. So you don't have to check actually in your JavaScript console in the browser if there's any error and have to debug it. You can do it up front. And yeah, this is not a real Elm session, I'm afraid, but so the things we liked about Elm and why we picked it up is it's functional, static type, it provides stateless, immutable data, and you can use all this pattern matching recursion, which is very nice for us because we render the UI from the graph, and then we have to do a transformation over the graph result. And then also it provides an architecture, even if it changed now, which is kind of straightforward. So just a hint, if you want to use Elm and try Elm, you probably have to keep in mind that they will have breaking changes, and it's not going to support reactive programming anymore. But actually, it's getting easier. It gets more close to Elixir and Elm, Elixir and Erlang. So it will be more like event handling in general, and just a few renaming. Cool part was the time traveling debugger, because it's static type, and you can record all the events in time. You can replay them as well, and this is kind of nice because you can see actually what is going wrong or what behaved in what way at a certain stage. And for us, very important was the semantic versioning of the package manager. So now, since we almost replaced React.js, we don't have any troubles with continuous integration. The build is much faster. We don't get so many dependencies, and it just works. Once it compiles, it just works. And again, that means high productivity and low maintenance code. For a small company, that's really relevant, especially if you want to scale. And efficient data transformation, that makes it easy for us. And it turned out it's even a nice language to pick up for backend developers. So before, yeah, we had a lot of backend developers picking up React.js as well, but only to a certain extent. And then we said, okay, we trust you guys, you take over. But with Elm, it's now like we have a common understanding, and we have a similar approach on the UI part, like on the backend part. And it just suits well with the event-driven architecture. Right. I think we can skip that because it's a long list and we are running late already. So if you have questions, then I will. Yeah. Is there a mic?
I'm afraid we don't have time for questions.
Oh, okay. So. I'm sorry, mate, but just catch up with me later. Yeah, sorry for the delay, guys, and I hope you're not too disappointed. It wasn't less code-centric talk, but maybe it gives you some inspiration for the problems you have to deal with, to think a bit broader and to think how you can use maybe even Elixir in a different approach. Thank you.